Before we start question number 1, if you have not read the intro above, please pause this video and go read that intro so you know what we're talking about in question 1. So again, go ahead and pause this if you've not read everything above. Read it first and then come back and unpause the video. Now that you've read everything above, question number 1 asks us to create a table to show how many people will receive the email on days 3 through 7. So in order to create a table, first we need to recognize what our variables are. So our first column here should represent the independent variable, the thing that's going to happen on its own. And in this case, we're talking about number of days that are passing by. So we can label our independent variable as number of days. And since we're talking about days, let's label that D. Then we want to think about what are we doing. So every day we're sending an email to multiple people. So people is going to be our dependent variable, depends on how many days have passed. So let's label that as number of people. And because we're talking about people, which is P, we'll label that P, and then to keep with our function notation, P of D. So then we're going to look and see what's going on. So it says up here, on day 1, Bill Waits starts by sending the email out to his 8 closest friends. So we can say day 1, it was sent to 8 people. Then it says he forwards it to 10 people so that on day 2, it is received by 80 people. So on day 2, we have 80 people. So because each person sends it to 10 people, we are multiplying that by 10 to get from that 8 to that 80. So if we want to go to day 3 and all of those 80 people are sending out 10 emails of their own, we can take 80 times 10, which would give us 800 people on day 3. And then those 800 people are going to each send it to their own 10 people. So to figure that out, we can take 800 and multiply by 10, which would give us 8,000. And then for day 5, we can take 8,000 and multiply by 10, which would give us 80,000. On day 6, multiply that by 10 again, we get 800,000. And then on day 7, multiply by 10 again, we get 8 million. So let's look at these follow-up questions. In letter A, it says, what pattern do you see? And we talked about that each time we're moving from one to the next, we are multiplying by 10. And so then letter B asks us if this is arithmetic or geometric. And since we are multiplying by something each time, that's going to give us a geometric sequence. So this is geometric. Remember, if we add each time, that's arithmetic. And then letter C says, does this sequence have a common difference or a common ratio, and what is it? So geometric sequences have a common ratio. So here we can say common ratio. And that common ratio is the number that we multiply by each time, and in this case, the common ratio is 10.